Welcome back to Dr.JIN's channel. Today, we are going to talk about a very important concept, which is Gastrin-Acid Negative Feedback. You will remember that in the previous video, I showed a curve. Because if you take some food, the food will stimulate acid secretion from stomach, and the rate of the acid secretion will increase gradually, and at some point the rate of secretion of hydrogen ion will decrease. So it give a lot of people a thought: is there some inhibitory mechanism existing during the gastric acid secretion? Yes. Today, actually, we introduce you a central rule for the gastric acid secretion. We called Gastrin-Acid Negative Feedback. Okay, let me tell you. When you take the food and enter your stomach, and when the food can distend your stomach some degree, which will stimulate the vagus nerve, eventually some kind of acid will secrete. And when acid secrete, it will convert. Do you remember? It will convert the pepsinogen, which is secreted from the chief cell, to active pepsin. Then the pepsin started to digest protein. It will cleave some protein and into amino acid or polypeptide. The amino acid and the polypeptide we call peptone. Okay, actually this kind of peptone actually is a stimulus. This kind of peptone at the lumen can stimulate the G cell, which is located at the antrum. Then the G cell will secrete gastrin. The gastrin, which is released to the circulating system. When the gastrin eventually will target to the parietal cell and the ECL cells. When the gastrin target the ECL cells, it will induce ECL cell to release what? Histamine, correct. When the gastrin target to the parietal cells, will induce the parietal cell to release hydrogen ion. Okay, now actually in the gastric phase of gastric acid secretion, the hydrogen ion concentration will increase and the pH value will decrease. Do you think it will decrease until which kind of the concentration for the acid? It cannot decrease forever. At some time, it have to be stopped by some mechanism, correct? Okay, listen carefully. When the pH value in your stomach, or we can say in the antrum, below 3, pH value below 3, the hydrogen ion, the luminal hydrogen ion, will stimulate the D cell, which is located antrum. And the D cell will secrete one polypeptide. What's the name? Somatostatin. And the somatostatin secreted from D cell will bind on its receptor on the G cell. And the G cell eventually will stop gastrin release. I want to say again, once the stomach pH value is below 3, the hydrogen ion will stimulate the D cell, which is located antrum, to release somatostatin. Then the somatostatin will bind on the receptor of the G cell to inhibit gastrin release. This cycle we call Gastrin-Acid Negative Feedback. This cycle, this negative feedback is very important because it will very high related to the clinical disease. A lot of the stuff today I talk, if you see a lot of disease, for example, like duodenal ulcer disease, gastrinoma, pernicious, anemia, for example, a lot of this gastric-acid negative feedback play a very important role for the pathophysiology foundation for this disease. So for next video, we will talk about some clinical relevant stuff, some disease, and the gastric-acid negative feedback relationship. Okay, thank you for watching. See you next time.